Okay, good morning. Welcome to
SuperMath156.
So we had a fun little conversation today about geometry. So we're studying three-dimensional geometry.
Yep.
And on our plane, everything is nice and flat.
Yeah.
And so we did a problem today about perpendicular planes that reduced to a triangle, which we could pretend was in one plane. But some of the most important things, he's driving a race here. As mathematicians started studying geometry, they noticed that not everything is flat. Right, give me an example of something that's not flat.
The Earth isn't flat.
The Earth is not flat. So when you have spheres, and you're talking about not through the sphere, but on the surface of the sphere, you can have strange things like triangles that have 390-degree angles and things like that. So this was studied by Gauss, Lobachevsky, and Bolyai, I think is how you say his name. And this was in the 1700s. And then later on, a German mathematician named Riemann sort of quantified a lot of this stuff and put it into really rigorous math. And that led to something really interesting. Einstein. And from 1906, I think, to like 1919, I think, is when he was kind of working on general relativity. Something like that. Early 1900s, about 100 years ago. Okay. And so he noticed a couple of things. One is the way starlight bends around the sun. So if you have a star here, it turns out that Newton's physics, have you ever heard of Isaac Newton?
Yeah.
Isaac Newton's physics says starlight bends around the sun a little bit. And general relativity predicts it bends exactly twice as much, actually, so I don't even know how I would draw that. Okay, so the bending is twice as much, however you would quantify the bending. But it's definitely different.
Yeah.
And then in 1919, actually, there was an exhibition led by an English astronomer named Arthur Eddington, and they found that it was twice as much. And it was a really cool expedition. But another interesting thing that came out of this geometry, which Einstein used, again, he used Riemann's geometry, relates to the planets. So here's the sun, and the planets' orbits are ellipses. And it turns out that those ellipses also rotate. Very slowly, super slowly, but they rotate. So for Mercury, it was about 42 arcseconds per century. So the rotation of this ellipse, so like, sometime way in the future, this ellipse is going to be rotated over like this. And what an arcsecond is you have 1 degree, which is divided up into 60 minutes, so you can think of a degree kind of like an hour.
Yeah.
Divided up into 60 minutes, and those 60 minutes are divided up into seconds. So 1 degree is made up of 3,600 arcseconds. Now 1 degree is not a very big angle, right?
No, it's very tiny.
In fact, this is a huge exaggeration of 1 degree.
Yeah, that's more like 20 degrees.
So, well, probably more like 5. But imagine dividing this up into 3,600 parts and then taking 42 of them, and that's the amount of angle that Mercury changes in 1 century.
Whoa.
Okay, but astronomers noticed this and they couldn't figure it out. And Einstein's general relativity, which is based on curved geometry, explained it and got it, basically right on, 42 arcseconds, which is amazing. And by the way, the other planets also rotate like this. The orbits of the other planets rotate much more slowly. Venus, I want to say, is like 8 or 9. Can't remember. 8 or 9 arcseconds per century. Earth, I think, is around 4 arcseconds per century. So in other words, it's going to take the Earth 900 centuries for its orbit to shift 1 degree.
Whoa.
Okay, so it's amazing they can even measure this, actually. It's such a slow effect.
I mean,
how
do you even see that angle?
Right, well, this is some of the amazing work that astronomers do. Right, it's amazing to me that they can measure stuff like this. It's so small, and it's occurring over the course of a century. Maybe for a family math project, we'll actually show how small this is. We can go out to a football field and show Like if you go the length of a football field, you go 1 degree. You start at like one goal and you go to the other goal post, and then you go for 1 degree. How far do you go? And then how much is 1 minute? How much is 1 arcsecond? Okay. So, but this is kind of one of the neat things about geometry is it's helped us understand the world. And as we're the basic geometry we're studying right now, flat, planes, cubes, triangles.
What's left of cubes?
What's left of cubes. That helps us understand flat geometry. And then as we move later on in studying curved geometry, we can start understanding some really amazing stuff. All right?
Yep.
All right, cool. Good morning, huh?